Students, in this video we will learn IUPAC rules for the nomenclature of alkanes. We must know what is meant by nomenclature. Nomenclature means assign the names to given organic structures or draw the structures of the given organic molecule. If names are given, then we are able to draw their structures, or if structures are given, we are able to assign their names. This is known as nomenclature. That is naming of alkanes. And what are alkanes? We know, students, alkanes are saturated hydrocarbons in which all the carbon atoms are connected with the help of single covalent bond. All the carbon atoms are connected with sigma bonds. Such molecules are known as alkanes. We will study IUPAC rules for the nomenclature of alkanes. IUPAC means International Union of Pure and Applied Chemistry. These rules are given by International Union of Pure and Applied Chemistry for the nomenclature of alkanes. Let's see what are the rules. The first rule is locate the parent chain. It means if the structure of organic molecule is given to us, then what should we do first? First of all, we will find the parent chain. What is the parent chain, students? It is the longest continuous chain of carbon atoms independent of the direction. It means parent chain must be longest, it must be continuous, irrespective of its direction. Now, let's try to understand this rule with the help of example. If we see the example of molecule consisting of, we have CH3, CH2, CH, CH3, CH2, CH3. Now students, this is a molecule which is given to us, and first of all, for assigning the IUPAC name to this molecule, what should we do? First of all, we will find the parent chain. Now here we can notice this is the straight chain which consists of 1, 2, 3, 4, 5. This chain consists of 5 carbon atoms. So how many carbon atoms are there in this chain? There are 5 carbon atoms. So here we write 5 carbon. Total carbon atoms are 5. In the straight chain we have 5 carbon. Now there is another chain. Let's see what is the second chain. This is the chain, students. Count the number of carbon atoms in this chain. 1, 2, 3, 4. This chain consists of 4 carbon atoms. So we will write the number of carbon atoms in this chain. We have 4 carbon atoms here. 4 carbon in the second chain. Now the third chain in this structure is, this is the third chain. How many number of carbon atoms are there in this chain? 1, 2, 3, 4. There are 4 carbon atoms in the third chain. So we will write the number of carbon atoms in the third chain. The third chain contains 4 carbon atoms. This is the branch which is attached with the parent chain, right? And this is the parent chain, students. So we will see, we will compare these number of carbon atoms. The chain which consists of 5 carbon atom, obviously this chain is the longest chain. So this is the straight chain. This chain is the longest chain in this molecule. This is the parent chain in this molecule. Now students, let's see the next rule. Now students, the next rule is if there are 2 chains of equal length, then the chain which contains the larger number of branches, the larger number of substituents will be selected as parent chain. 2 chains are of equal length, then the chain which contains the larger number of branches or the larger number of substituents will be selected as parent chain. Now we will understand this rule with the help of some examples. If we have a molecule like this, we have CH3, CH2, CH, CH3, CH3, CH3. CH2, CH2, CH3. This structure is given to us, and we will find which is the parent chain in this structure, students. Now we will see, count the number of carbon atoms in this straight chain. How many carbon atoms are there? 1, 2, 3, 4, 5, 6. This is the straight chain which is made up of how many carbon atoms? This is made up of 6 carbon atoms. So we write the number of carbon atoms here. In the straight chain we have 6 carbons. 6 carbon in the straight chain. This straight chain has 6 carbon atoms, but it has just one radical. One radical is attached, or one branch is attached with the straight chain. Straight chain is made up of 6 carbon atoms and just one branch is attached with the straight chain. Now see the second chain. This is the chain which is made up of, this is the second chain, students. This is the second one. It is made up of, count the number of carbon atoms, 1, 2, 3, 4, 5, 6. This is the second chain which is made up of 6 carbon atoms. If we take this chain as a parent chain, right, then how many branches are attached with this chain? 1, 2, 3. So we will write how many carbon atoms are there in the second chain. In the second chain we have 6 carbon atoms. Again we have 6 carbon atoms. Now there is another chain, students. This is the chain. This is the third chain. Count the number of carbon atoms. 1, 2, 3, 4, 5. The third chain contains 5 carbon atoms, although there are 1, 2 and 3 branches. There are 3 branches, but this the third chain consists of 5 carbon atoms. So we write the number of carbon atoms in the third chain. The third chain is made up of 5 carbon atoms. So what is the rule, students? Once again we will see the rule. If there are 2 chains of equal length, here we can notice there are 2 chains which are made up of 6 carbon atoms. Straight chain as well as this chain. They are made up of 6 carbon atoms. Then which chain should be taken as the parent chain? According to the rule, the chain which contains the larger number of branches. If we take the straight chain as a parent chain, then it contains just one branch, just one radical. But if we take this chain as a parent chain, it contains how many branches? 1, 2, 3. So we will take this chain as a parent chain and we will specify branches here. These are the branches, students. So we will specify the branches. Here we have the first branch, 1, 2 and 3. These are the 3 branches. So what is the parent chain in this molecule, students? This is the parent chain. We have taken this chain as a parent chain. I hope this rule is clear to you, students. Now students, we will study the third rule. According to the third rule, number the chain starting from the end nearest to the substituent. It means once we locate the parent chain, then we will do the numbering of the parent chain. We will do the numbering of the parent chain in such a way that we will assign the lowest possible number to all the substituents which are attached with the parent chain. We do the numbering in such a way so that we will assign the smaller number to the substituents. Let's study this rule with the help of some examples, students. Let's see the first example. Here the first example which is given. If we have a molecule like a molecule which is made up of CH3, CH2, CH2, CH, CH3, CH2, CH3. This is the molecule, students. Now we do the numbering. First we locate the parent chain in this molecule, which is the parent chain here. See this chain which is made up of 1, 2, 3, 4, 5. This chain is made up of 5 carbon atoms. The next chain, 1, 2, 3, 4, 5, 6. This chain made up of how many carbon atoms? 6 carbon atoms. And this chain 1, 2, 3, 4. This chain made up of 4 carbon atoms. It means there are 4 carbon atoms in this chain. There are 5 carbon atoms in straight chain, and there are 6 carbon atoms in this chain. So which is the longest chain, students? Yes, of course, this is the longest chain. This chain consists of 6 carbon atoms. Now we find the parent chain here. If this is the parent chain, then this is the radical or the branch. We encircle the radical here. This is the radical, students. Now students, we do the numbering. Do the numbering in such a way to assign the lowest number to this branch. Now if we do the numbering from left hand side, 1, 2, 3, 4, 5, 6. If we do the numbering from left side, methyl radical is here and it is attached with carbon number 4. What is the position of branch or the methyl radical here? It is attached with 4th carbon. Right, students? Now do the numbering from, if we do the numbering like this way. If we do the numbering like this way, then we will see what is the position of methyl radical. 1, 2, 3, 4, 5, 6. If we do the numbering like this way, obviously you can notice here methyl. What is the position of methyl radical here? Methyl radical is attached with carbon number 2. So, I'm sorry, 3. 1, 2, 3. This is the 3rd carbon. If we do the numbering by this way, then methyl radical is attached with carbon number 3. So we will write the position of methyl radical. Here we will write the position of methyl radical. It is attached with carbon number 3. Now which is the smaller number, student? Compare these numbers, 4 or 3. Which is the smaller? Which is the smaller, 4 or 3? Of course 3 is the smaller number. 3 is the smaller number. So we will do the numbering like this way to assign the smaller number to the alkyl radical. So this is the correct way of numbering. We will do the numbering like this way. I hope this example is clear to you, students. The next rule. If identical radicals are present more than once in the chain, then the number of alkyl radicals are represented by adding prefixes di, tri, tetra, etc. with the name of the radical. It means if on the parent chain we have same types of more than one radicals, same types of more than one radicals are present on the parent chain, then to specify how many number of radicals are there, we use these terms, that is di, tri, tetra. It means if we have same types of 2 radicals, then we use the term di. If we have same types of 3 radicals, then we use the term tri. Similarly, if we have same types of 4 radicals, then we use the term tetra. Now let us study this rule with the help of some examples. Let's see, students, what is the first example. For example, if we have a molecule like CH3, CH2, CH, CH3, CH, CH3, CH3. Right, students? So here we can notice, students, this is the parent chain obviously. This is the longest chain. How many carbon atoms are there? 1, 2, 3, 4, 5. This is the longest chain which consists of 5 carbon atoms. And how many radicals are attached with this chain? We can notice here, students, there are 2 radicals which are attached here. This is the first radical, the first one, and the second one. Both the radicals, they are made up of single carbon atom. This radical is made up of single carbon atom. This is methyl radical. This radical is also made up of single carbon atom. This is also methyl radical, right? How many methyl radicals are there? There are 1, 2. There are 2 methyl radicals. So same types of two radicals are there. So we use the term di. Now which radicals are there? Methyl. So we will write dimethyl. Dimethyl. Now we'll number the parent chain to specify the position of these radicals on the parent chain. If we do the numbering from left hand side, 1, 2, 3, 4, 5. Here we can notice first methyl radical is attached with carbon number 3 and the second methyl radical is attached with carbon number 4. Now if we do the numbering from right hand side, 1, 2, 3, 4, 5. If we do the numbering from right hand side, the first methyl radical is attached with carbon number 2 and the second methyl radical is attached with carbon number 3. Here we do the numbering from right side. What is the position of first methyl radical? It is attached with second carbon. And the second methyl radical is attached with third carbon. Right? So if we do the numbering from right side, first methyl radical is attached with carbon number 2 and the second methyl radical is attached with carbon number 3. But if we do the numbering from left side, the first methyl radical is attached with carbon number 3 and the second methyl radical is attached with carbon number 4. Now compare these numbers, 3, 4, 2, 3. Which are the lower numbers? Obviously 2, 3, they are the lower numbers. So this is the correct way of numbering. So we do the numbering from right side. So what is the correct way of numbering, students? This is the correct way of numbering. That is, we do the numbering from right hand side. This is the correct way. Now assign the IUPAC name to this molecule. There are two methyl radicals. So we use the term dimethyl. Before writing dimethyl, we must write their positions. As we have noticed, what are the position of these methyl radicals? 2, 3 hyphen. Then we write dimethyl. And what is the name of parent chain? In the parent chain, we can notice how many carbon atoms are there? There are 5 carbon atoms in the parent chain. So its name is started with pent. Penta shows there are 5 carbon atoms. Penta shows there are 5 carbon atoms. All carbon atoms are connected with the help of single covalent bond. So what is the name of parent chain? Pentane. What is the name of parent chain? Pentane. So what is the name of this molecule? The name of this molecule is 2,3-dimethyl pentane. I hope this example is clear, students. Now let's see one more example. Suppose if you have a molecule like CH3, CH2, CH3, CH3, CH, CH3, CH3, CH3. Okay, student, we have this molecule. We find the parent chain in this molecule. We will apply the first rule and find the parent chain. This is the straight chain. This is the longest chain. Obviously, this is the parent chain. Along with the parent chain, we have methyl radicals, right? All the radicals, they are made up of single carbon atoms. All are methyl radicals. How many methyl radicals are there? 1, 2, 3, 4. How many methyl radicals are there, students? We have 4 methyl radicals, since all the radicals are made up of single carbon atoms. So all are methyl. How many methyl radicals are there, students? 1, 2, 3, 4. 4 methyl radicals. Same types of 4 radicals. So to specify there are 4 radicals, we use the term tetra. tetra. Tetra shows there are four radicals. And which radicals are there? Methyl. So we use the term tetramethyl. Tetramethyl. Now students, we find the position of methyl radical, and what is the parent chain here? We find the parent chain. Now if we do the numbering from left side, 1, 2, 3, 4, 5. Two methyl radicals are present with carbon number 3, that is 3, 3, and two methyl radicals are present with carbon number 4, 4, 4, 3, 3, 4, 4. Right students? But if we do the numbering from right hand side, then we can notice here 1, 2, 3, 4, 5. If we do the numbering from right hand side, two methyl radicals are attached with carbon number 2, and two methyl radicals are attached with carbon number 3. Now compare these numbers, 3, 3, 4, 4 or 2, 2, 3, 3. Obviously 2, 2, 3, 3, they are the lower number. That's why we do the numbering from right side. We do the numbering from right side. Now if we do the numbering from right side, what are the positions of these methyl radicals? 2, 2, 3, 3, tetramethyl. Since there are 4 methyl radicals, so 2, 2, 3, 3, tetramethyl. And what is the name of parent chain? There are 5 carbon atoms in the parent chain, so the name of parent chain is pentane. Ane is used as suffix since all the carbon atoms are connected with the help of sigma bond. So the name of parent chain is pentane. Now students, we will write the name of the parent chain. We will write the name of this molecule along with the parent chain. It is, we write the position of methyl radical 2, 2, 3, 3. Then we place hyphen. 4 radicals are there. We use the term tetra. Tetra. Which radicals are there? Methyl. So tetramethyl. And name of the parent chain is pentane. So we write here pentane. So what is the IUPAC name of this molecule? The IUPAC name of this molecule is 2233 tetramethyl pentane. I hope this example is clear to you students.